这样叫你啊，不要，会怕的。
Oh, nice man.
我今天讲 protection， 这个actually if possible if any questions are directly ask 那边会等那么久了，因为我是那边在 protection department 4天罢了，我学到我就那么多了。可是
快点。
你觉得你明白的话就可以明白，不明白的话直接问，然后我不明白就直接 skip 掉它，可以了。
OK。
So what's protection? 因为 protection is the protect.
Okay.
Protect, want to protect a lot of things. System, stability, all the things in there. But we mainly look at 3 elements. If we take out 3 elements, everything should go together as well. First element we look at is the voltage. Second, frequency. Third, we look at the current. By voltage, high voltage, you cause flashover. Low voltage, you cause damaging to things. Light cannot work, anything cannot work because low voltage. Frequency, too high frequency cannot, too low frequency cannot. Too high frequency, later the motor or rosak or it's not spinning out of condition. And also our generator also not doing well because the frequency is directly linked to our generator. Current, we cannot have it too hot because if it's too hot, the cables will melt, that's all. So these 3 aspects we look at for protection. Protection, the philosophy is we look at faults. The name is called protection, but we don't actually protect things. The protection only kicks in after a fault happens. For example, this is what we call a bus bar. Power flows here, goes out here. These are what we call breakers. Our philosophy is, if a fault happens here, let's say, fault is there, okay, another thing is, fault there are 2 types. One is permanent, and one is transient. Permanent fault is normally hits and it stays there. For example, banana tree, stick onto the conductor. I think cable, they dig, broken. That's permanent fault. Transient fault, lightning, that's all. Or maybe birds or squirrels, lightning. A bit only, very short time. Permanent fault, normally, we want to isolate and keep it locked out. We don't want to reconnect anymore. Transient, for example, lightning, we want to reconnect it. That's what we call auto reclose. Because if you do not auto reclose, all the staff punya KPI hancur, you know. Oh, no more bonus already, cannot. So we must jaga, auto reclose. If hit, must auto reclose. Auto reclose got timing itself. Higher voltage transmission, 132, 275, you have auto reclose within 4 milliseconds, must reclose already. 100 milliseconds. For distribution, 11 kV and 33 kV, it goes up to 4 seconds first time, 30 seconds, and then 2 minutes. 3 times you auto reclose. Only after, if 3 times you cannot auto reclose, then it determines it's a permanent fault and then lock out. Here, it's a fault happens here. Ideally, we want to break this one, activate, this one activate, so power can flow here, through. The customer not affected, only here isolated. Let's say this one doesn't work, with the break here. This one doesn't work, with the break here, with the break here, with the break here, like that. You enlarge and enlarge. Our philosophy is to make sure that the isolated area is as small as possible. That's anything protection engineer they want to do lah. Moving on, next topic is protection. We take data. We take data from equipment such as instrument, equipment, CT, and VT. There are 3 types of relay that we use. Current transformer, induction voltage transformer, and capacitive voltage transformer. This one is pretty simple. A line, like that. As simple as that. Just coil around it. It takes up, steps down reading, gets a reading you want. Induction voltage, same case. This one, but for higher voltages, 500 kV, you use CVT. CVT is quite mafan a bit. It cuts the voltage in a proportion using capacitor first, and then only takes in things. Advantage, it can go to high voltage. Disadvantage, it cannot read harmonics. This one can read better harmonics. And okay, moving on. Let's go to protection zones. Protection zone, we want things like, let's say it's a breaker here, and one relay here, one relay here. We want to wire the relay so that this relay will look this way, and this relay will look this way, so that there are no blind spots. We do not have blind spots.
Sorry, we're having class?
No.
Yeah.
We're just having fun here.
Oh, okay.
Yeah.
So can we come in?
Yes, yes, true. How it is essentially is we look at the earthing. If earth is on this side, then we juggle this part. If earth is on this side, then we juggle that part. Okay, that's all for today. Still be close back to say that, hey, is the fault finished already? Can we reclose back or not? But if it's three things are straight away gone. No more. We don't reclose anymore. And also overhead lines and underground cable. Overhead line, we have auto reclose because we want to find some movement to supply. But underground, there's no such thing as lightning. So in theory, there's no such thing as a transient fault. Sure, with to be permanent fault. When it's permanent fault, we straight away lock out, no auto reclose. Until we lock out and then send a signal, hey, come fix this, I'll fix this. Okay, now I want to talk about our main and backup protection. Main protection, we normally use this current differential. This is also what we call unit protection. That means we protect in one unit only. We look at one unit and protect that unit. This one backup, we call distance protection. Okay, but this one what happened here? Let's say there's one line here. You want to protect this line. If a fault happens here, how do we detect? We have two CTs. We use CT only, we don't use anything. CT, here we give a current. Current, we give you two information. A magnitude and a phase. Here we have a magnitude and phase. Let's say power flow is this way. If a fault happens here, here should be low right. That means here the current, it drops. It drops current. Because a lot that is absorbed here already. Here is normal. Current differential, as the name suggests, it means that these two values, you minus out, cancel off, should be going near to zero. Near to zero. Why is it not zero? Because there's some losses here, there's something here, there's a phase change, but near to zero. Let's say it's 1 amp, because step down already. We step down a lot of times already. 1 amp, 1 amp. This one should be around 0.02. And the angle should be plus 1 as well. Almost zero angle. This is what I call current differential. If we set up coincidence setting, if these two exceed 0.02, then we treat this and we treat this, isolate the fault. And then we try to reconnect, reclose. We reclose, then okay, that's another story lah. But this is what we look at. This is a technique used. We determine from two sides and to protect everything in between. Everything in between. That's why I call it unit protection. Distance. Distance, that means, okay, if I go to distance here, let's say a fault happened here. Fault happened here. This reading and this reading actually is still the same. Because it's one same current. And then fault comes down here. So this one, it doesn't care about that. It will not respond. It will stay the same. Because protection philosophy, we want to treat the nearest and the most isolated part. We don't have, because of one small thing, trip here, until the whole nation blackout. We don't have that happen. That trip, we isolate the part. That trip, isolate the part. Don't go make small things become big. So, if here fault, you must say, not our problem. Never problem. Never problem, no? Go find never problem here. So, here is one, it's called one zone, separate by zone. This should be another one, and here should be another one. You respond, this one and this one should respond to this one. And that will trip out. This is what I call current differential. As basic overall, in class you'll learn something more about this stuff. Next, we have distance. Okay, distance means in a line, here to here has a certain set amount of impedance or resistance. If a fault happens here, then the impedance is actually shorter, right? Z. Compared to regular Z, this one is actually shorter. And that's why you shouldn't, that's how you detect the fault. With this, for this one distance, you need two information you need. To find Z, what you want? What information you need to find Z?
The voltage or current.
Oh yeah, the U mobile answer, you know, not you, the rest cannot answer. You need a voltage, I need a current. V equals to IZ lah. So you have these two values, you can get a Z. If the Z is in range, normally, no fault, okay, the Z is okay. But suddenly a fault happens, the Z drops. And that's where these two come in, and then you trip off. This one acts as a backup to this one, because this one, if the Z happens here, fault happens here, this one also can read, you know. You read it for how long also. Normally, we will let the current differential take action first. Current differential cannot take action, then only the distance will kick in to take action. That's what I see. Okay, distance, we want to cover, we cover in zones. 80%, 120%, and 200%. First range, we cover 80%. Next range, 120, and then 200. If a fault happens here, first thing of action, always the current differential take action first. That's why the delay, the backup, we put a delay time onto it. A fault happens, and then there's an AND gate. A fault happens, you ring a timer. Timer must elapse, positive one signal, and then at the time, still you have a one signal, then you need a trip. If it comes in here, timer elapse, and put a one signal, but then the main protection kicks in already. This one gone, 0, this one 0, so backup won't come in. Because main protection, normally you will be closed, but backup protection, you will just lock up because say, hey, your main is fucking up and we need to fix it. So fix it now. We're not going to be close it back together. And exact question, I think they'll ask, why 80%, why not 100%? The answer is CT and BT, they have accuracy. The line is not a short line, it's not 100 meters, it's like cam. So there's sure to be a plus minus or a Z, which is not going to be close enough. From there, you need to take into account. We do not want the fault to happen here, but then this one activates and picks up and POM! Trip the whole thing. That's why we want to isolate more. If what happens here don't care, here don't care. You mobile say we're good. This one is happening. So if the fault happens here, we want to let this take action first. This cannot take action, then only here take action. So only put 80%. We put 100%, later plus minus a bit. If what happens 101% here, this one trip off. Oh, not good, no? Yeah, so okay, we covered main and covered distance.
3 minutes more.
3 minutes more. I think I almost finished already.
Like if you pass,
What else can I cover?
when you break it, then
Just now it's not 3 minutes.
internal movie. I think
Okay, transformer fault.
假装你查到要去，
下次当年。
等下去看。
就是我。
你进来过后就是你啊。
Yesterday we went lecture teach about something. Restricted earth fault. What happens here is it's a CT, all joined together. CT. This is your relay. If the fault happens here, the current goes in here, current goes in here, here. These three current should end in this current, and should be like this. Nothing should happen. But if the fault happens internally, let's say on one phase only, the current comes in here, goes up, but this one, faults happen. The current will not be balanced, and this one will be activated. And that's when you trip a fault. It will happen within the thing and within the transformer itself, not outside transformer. Okay. Okay, I think enough already. People are going to class already.